So hey everyone, my name's James, and feel free to interact in the YouTube chat. I've got it up as well. Be happy to answer any questions or talk about anything. But my history in security, I came in sort of the IT systems path into security, um, and so really, I think what I've been able to learn of value is working at a lot of different size companies, whether it's startups out of San Francisco to mid-size enterprises to now. Uh, uh, Larger companies like PagerDuty, where I'm at currently, really getting to see a lot of the beginnings of this field and how CI/CD security has really so quickly evolved and a lot of the confusion. So my goal today at a high level is really to clear up some of that confusion that can happen around GitOps pipelines and really just pipeline security in general. And so first, just the objectives for today, what we're going to be going over is why pipeline security, why it's something you should care about, why moving security into your pipeline is a good idea. And then how to really prioritize and think about what is essential for getting in pipeline and just in a myriad of different tools and approaches, what we should really pick. And so let's take a couple minutes at the start and think about how this challenge came about. Um, Really, with the cloud, the way I saw security at a lot of organizations is the primary emphasis was on security operations, which was much more closely tied to runtime and to um, systems administrators side of the field. And so it was a lot of close knit relationships between systems engineers working on patching servers and trying to update things as they saw them, combined with getting log sources into a SIM, triggering alerts, and responding to them. And that was sort of the main goal of most security teams. Where I saw dedicated application security functions was only at really large enterprises that had a good case to make a good business case for mitigating fraud, mitigating user impersonation. And those larger organizations would have dedicated application security teams. But with the cloud, we saw a lot of that sysadmin crowd shift into DevOps. And so a lot of cloud configuration, you had a lot of people learning how to code and how to run pipelines as the focus of their job. And with that, security had an opportunity to come alongside them and get more into the configuration layer. And so that's really this differentiator that I see here of I think of cloud security as doing scanning and enforcement of the configuration and then scanning and response, incident response of the runtime protection. And so really it's how do you marry those two things together? And we've seen a lot of push from an industry-wide perspective of things like CNAP, which is an attempt to all-in-one these tools, where you have different major providers arguing that the runtime insights are better, or the configuration scanning is better when it's powered by runtime insights, right? Is how the pitch goes. But really, I think a key piece that's missing from this perspective is who's using these different tools. Because I really think it is different users with different goals. A developer who is setting up configuration, whether it's Terraform, whether it's actually setting up a monolith or setting up a microservice, that developer has different concerns than responding to a runtime incident. So I fundamentally think both of these things are pretty separate. And really, what securing GitOps pipelines allows you to do is to focus and enforce and hands off as much as possible the configuration scanning side by empowering developers, right? So this is the shift left mentality. And so, how do we get that visibility and risk reduction on configuration? So first, let's just look at an example. I think GitLab has the nicest setup for what a pipeline looks like. That's the easiest to understand just by looking at it. Is a developer is coding on their local IDE. They then push the code into their Git provider or their source code provider, which then builds and then tests and then does some kind of deployment option, usually to a staging environment before that's elevated to production. And really, the opportunity that exists here for security is to insert checks along each step of the way here. Um, and so let's look at some key challenges and opportunities that this presented. The main opportunity of getting security into pipelines is reducing the time it takes to fix vulnerabilities, because there's plenty of studies out there that show fixing a vulnerability at runtime, once it's already out, first of all, it could be exploited. But second of all, it takes much more testing to actually get something fixed at that stage, because it's already completely running. Developers have to context switch in order to tackle it. But really, if they're alerted of that vulnerability closer to when it happened, it's a lot easier for them to change a version number when the application's up and running on their local machine than it is to wait till it's out into production and see if anything's going to break. Second, there's more visibility into business risk when you're able to do this. And so I remember still my first time really having the assignment to get into pipeline security was just from the CISO saying, figure out what the developers are doing. And really, that's the opportunity that exists here. Is a lot of smaller security teams that didn't have that application security focus that the larger enterprises had, they didn't have this opportunity to get visibility into risks that they were just completely unaware of. But now, sets of tools that enable configuration scanning really allow those smaller teams to elevate their skill set, by providing that feedback directly to developers and really opening up new relationships, right? Because historically, security operations teams really only had relationships with like systems administrators, systems engineers. But now there's a greater impetus to get those operations folks who traditionally haven't talked to developers more engaged with developer relations. Finally, there's a real opportunity here to automate pieces of remediation. Now, there was a time when I was new enough at this that I thought that the fully automated patch cycle would be possible. But I've since learned that trying to chase that is an ever failing reality. But it is possible to automate small pieces of this. So instead of thinking, how can I automatically patch every dependency I have up to the latest version? Instead, you can think, how can I automatically get this to the right team at the right time to focus on this initiative? But a lot of organizations have really failed at this shift left opportunity of getting security in the pipeline because of the challenges. First, there's just an overwhelming amount of tool choices. And until you start walking down the path of failing at one of these tools, it's really hard to know if you're making a good decision or a bad decision. Because if you pull up the websites for almost every tool provider that's out there, whether it's CNAP or CSPM or SAS, DAST, SEA, a lot of them on their product sheets will say that they check all of these different boxes, right? I can't tell you the number of sales calls I've been on with, especially CNAP providers are guilty of this, where it says, we do vulnerability scanning, we do vulnerability protection, we do runtime insights, we support Kubernetes. But the depth of the support is so wildly varying and means such totally different things that it's really challenging to try to pick the right tools at the right time. And so that's going to be the majority of what we're talking about going forward, is how do you pick the right tools at the right time? But second, and this is just as important, is this isn't entirely a technology issue. It can also be a people issue, where if you're going to try to implement security in pipeline, you really need a lot of interdepartment trust to exist. And that takes place. I really fundamentally believe it has to happen at the executive level as well. There has to be buy-in from engineering leadership and security leadership that we're on the same team about this. And more importantly, to set realistic outcomes for what you're trying to achieve here. Because if you're just chasing endless security things to exist in pipeline, you can spend an almost unlimited amount of time and money just fixing vulnerabilities that are reported by various tools for different reasons. But if you don't have a clear goal in mind of, we want to reduce vulnerabilities, particularly around third-party dependencies, particularly around our code base, our first-party code, really the specific goals matter a lot in terms of prioritizing this stuff. And finally, a giant challenge is if your existing security team has the technical skills that are going to be required to really implement this well. And that comes about through pairing your security team with DevOps teams, especially, but also directly with developers. Because a lot of security teams are very used to a siloed experience where they're managing SIMs and EDRs, but they don't necessarily have an understanding of containerization, of pipelines, and really the application deployment workflow. And so that's another challenge that can only be overcome through both training and just intentionally forming relationships with other teams. So if we look at now just a more high level overview of what security options are possible here. I generally split these things into three categories, and the goal is to fix a vulnerability without any security involvement. Because frankly, the number of vulnerabilities that can be detected by these tools can be in the thousands and thousands and thousands, right? And so if I have 20,000 vulnerabilities discovered, and I have a team of 5 security engineers and 100 developers, it's pretty clear that we're not going to be able to get through that entire backlog, or something has gone amiss. And so when you're doing tool evaluations or vendor evaluations, this is the main thing that I focus on, is how can this tool allow something to get fixed without me being involved as a security person? Because usually security teams are significantly smaller than development ones. So the first place to focus is what can happen in the developer's IDE, the place where they're working. And now this has mixed results in terms of how much you focus on it, because there's a wide variety of ways in which developers interact with their IDEs. I've worked at some places where the developers are pretty junior and they're using basic text editors, or everything is very hacky. And for a situation like that, IDE integrations don't necessarily mean that much. Um, on the other hand, I've also been at places where we've invested in tools that say they have an IDE integration, but in reality, the IDE integration is terrible to use and is uh, just as time consuming as just relying on the in pipeline scanning. So it's important to evaluate, like, is this IDE set up, is this IDE plugin set up in such a way that it's actually helpful? And the green, yellow, and red here are meant to represent the various stages in which you might implement some of these tools. And so green is meant to be things I would suggest you do, even if you're a startup, things you do just to get working on some of these things. Yellow would be as you're scaling your security team into more of a mid-size or larger team, things to look at and invest in. And then red, I consider more advanced things to do as you're looking to mature beyond the things that we've talked about so far. So, first, in the IDE is a great place, first and foremost, to do secret scanning. And this is because if anyone's actually fixed a secret, it is a real pain if you've already committed the secret to the repository. Because you have to, after you've pushed up that change, then use a third party tool to redact all of the change history and then force push a new commit history to the branch. And so that's always a very scary thing to do, that no one really enjoys doing. And so if you can do secret scanning in the IDE, that's a huge benefit to developers if they're going to check it before they commit. The second thing is container scanning. And this is because there's great point and scan container scanning utilities out there, whether free or paid. And this is just an idea of where if you have a small development team, you can get a good idea of what vulnerabilities might exist on this image before I push it up. And then clearly SAST and SCA have a place in IDE for those same reasons. It's just that the risk that you're mitigating is more advanced than many startups really need, unless they have a compliance need pushing them in that direction. Then at the build stage, this is really the build is where I do the enforcement. And so the goal, you're never going to want to start with enforcement. And we'll talk about that later. But the build stage is where you really want to begin the enforcement of these things, and how you can check and both ensure visibility for your security team so they can do meaningful reporting of how many vulnerabilities exist, are they getting remediated or not. And then finally, the runtime area is where you're really focused on how am I able to respond to threats. And I always recommend guard duty for people here, because it is the easiest check the box security tool that's out there. It's not perfect, it has plenty of issues, but it is a great low hanging fruit that's cheap and cost effective for getting through that runtime protection. And then from there, you can evolve more into EDRs. I consider CNAP, I really think CNAP should focus mostly on runtime and think about that as your EDR for cloud and the runtime. So now, if we think about the different tool options that exist across these different types, there's really 3 options you can go with. you can go with open source tooling, built-in tooling, or paid. And what do I mean by built-in? By built-in, I'm talking about tools that come along with other providers. And so you would think that it would make a lot of sense to get your security scanning from the same place that's hosting your pipeline, right? So, like GitLab Ultimate made a lot of sense when you're thinking about, well, surely if they're the ones providing the security in pipeline, it's going to be the best thing. But unfortunately, a lot of built-in tools are almost always worse in my experience from the dedicated providers because they simply haven't dedicated the amount of time to really making that tool usable and surfaceable to developers. So I'd be really cautious about using built-in tools. I think the idea of being all in one can sometimes be better than the actual execution of it. Um, and then for open source, it's just important to recognize that open source never actually means free. And so I like to use open source. It's great for point in time scanning or to solve a problem quickly. Like if I need to get something in pipeline fast in order to either check something or to check a compliance box, it's a great opportunity to do something like that. But the long term maintenance tail on something like that is always going to be really difficult. And so that's why I do lean towards getting paid tools, but the hard part is figuring out which ones to get because they can be so expensive and there can be so much overlap between the tools. So let's talk about some implementation things to think about here. First is to think about primarily who the users of the tool will be. And this is when we think about that configuration and runtime scanning approach, my favorite security tools are the ones that aren't built for security teams. Because a lot of the time, especially in cloud native developer workflows, tickets are getting handed off to specialist teams instead of being solved by the security team themselves. And so if I'm buying an application security platform, especially, I want one that's going to make things as easy as possible, not for me, but for my developers. And if I'm getting a runtime protection platform that is very focused on Kubernetes security, I want it to be the best to look at from my DevOps team's perspective, um, even more than securities. And so, really think about and have the people evaluate the tool who are going to be the ones actually using it instead of forcing everything through the security lens, who are traditionally going to be focused very much on like the depth of the finding, the number of false positives, the time it takes to triage issues, the reporting capabilities. These are all the sort of things that security teams will emphasize, but they're not as important as like, does this make the vulnerability actually fixable? And then second, make sure you talk to them before you buy and implement it. So I've seen plenty of tool selection processes where a tool's been purchased and then we're asked the first time the using team is hearing about the tool is when they're being asked to help implement it. And that's really late and can create a lot of issues if the first time that the team is hearing about it is when they're being asked to help implement it. It's really important to involve them early in the decision. And so third, I wouldn't buy a configuration scanning tool that didn't support IDE integration, CI/CD, and some kind of reporting. And so, what I mean by that is a lot of these CNAP specific tools, the CI/CD integration is kind of like an afterthought that's difficult to do. But I think this should be one of the first things that you test with an integration is how easy is it to get this into my pipeline. Fourth is to, before you start implementing, think about the most elegant way you're going to set up the scan jobs. And so a lot of this is what's really great about, for example, Sneak's webhook integration is that it's very easy to turn on. But just think about, how am I going to actually roll this out and add the scanner to the various projects I have in my organization before you go ahead and make the purchase of the tool. And finally, for the actual rollout, this is the people always ask, like, when should we block builds? When should we actually halt processes? And I've always followed this to great success, where the first is just to deploy it in manual scan mode, where it's not automatically scanning ever, and that way the security team can do all of the testing that they need. But no developer is going to be complaining that like jobs are taking too long or things are going too slow, because that's going to be the main issue that happens is if a production deploy gets held up by 30 minutes because of a security tool that you're testing, you're going to create a lot of issues with your development team. So always start with manual and then start making it so that it automatically scans once you're sure that the scan time is acceptable. Have it run concurrently to other jobs to make sure that it's taking up the least amount of time possible. I usually try to have it run at the same time as test jobs. And then finally move forward to blocking builds on highs, and then eventually mediums and highs, and then lows. And so this kind of phased rollout ensures that you're going to be successful with not stepping on developer toes as you're going forward, and actually making sure that you get fully implemented and fully blocking eventually. Some success tips. First, get clear buy-in from developer leadership. Don't slow down pipelines, all things we've talked about. Set clear expectations on you're going to make through the vulnerability backlog and the priority of it. Know that when you buy a new tool, you are signing up for more vulnerabilities getting found. And so it's important that you have a realistic plan in place of how you're going to address those. Fourth is to use open source when you need something but don't have budget or buy-in. And so that's why I love tools like Scout Suite, which is a cloud configuration scanner, just for a quick scan to check things, especially if I'm just helping an organization out or something, just running a quick scan with that. As a low barrier to entry, just a quick scan. But I'm not setting up an infrastructure where I'm trying to maintain and deploy that on my own, because then I'm just sinking a lot of time cost into a single, very specific tool. I think built-in tools like Dependabot is what comes to mind, is great when you're just trying to check the box. And then finally, be prepared to quantify your progress when you're reporting. So the executive team is making a lot of investments into these tools, and they're going to want to see the return on investment that's happening from them. And so the best way to show that is just to think about in advance, just at a bare minimum, how many vulnerabilities were detected and how many were fixed. So now for the most interesting part is, what are some common security stacks I've seen to implement some of these things? And this is all, of course, just my opinion. So for startups, we've talked about guard duty is a great, really the focus, first of all, is with startups. It's just to try to check some basic security blocks without creating an overly large workload upon your small team that's just trying to ship a product. And so branch protection rules is something I really want to highlight as something that check a ton of compliance checkboxes and are great low-hanging fruit of just making it so that every merge request needs an approval to master. And so that is the main best, easiest thing to implement, just enforcing branch protection. And then guard duty on the runtime side, or whatever cloud native tool that you're using. I do think a WAF is worth trying to set up, even if you're a startup, because if you just check all of the basic rule packs, you probably won't cause many issues for yourself. And it's a great, just low-hanging fruit runtime protection there. As you're starting to scale beyond the startup stage, that's where you're starting to need something that's going to provide a little bit more insights and cover a little bit more bases. Because maybe now you're looking into actually getting a SOC 2 Type 2. Maybe you're looking into actually enforcing some different security things. Maybe you need an SBOM. So this is where SonarQube is a great open source option. Obviously, Sneak for a paid option for checking a lot of boxes all at once, where you can say you're doing SCA, SAST, all in a single place. And then my preference on Wiz and Sysdig is for static EC2 instances. I think Wiz is a great option, as well as just general cloud configuration scanning. I think Sysdig really excels at containerized environments and providing runtime rules there. And now you're really getting into more advanced things like considering Terraform guardrails. And so here's where you're either doing IAC scanning or setting up like service control policies within AWS to really thinking about what your infrastructure should look like and things you want to not allow. And same with DAST in pipeline is I wouldn't go with any legacy DAST provider because there's a big push in the industry right now, it feels like, against DAST. But a lot of that is against really legacy DAST, where it's like crawling a monolith web app. But when so many things are microservice based now, it's a lot more effective to just test the APIs directly. And so I think that's the benefit of doing DAST in pipeline with someone like Stackhawk, as opposed to a more legacy provider that's trying to crawl. As you check all of those boxes, then you can start thinking about more advanced security tooling. And so that's things like doing bug bounty programs, like creating custom SIM content, which is very close to what runtime application security is, and really focusing on those big picture uh, application specific use case guided content. And that's where you can really get a lot of value out of the manual effort. So finally, what should guide all of this? It's fixing one vulnerability. The biggest thing that I see security teams do is invest in a lot of tooling without a clear plan for how to fix something. And every demo you're going to be on is going to do a great job at showing you all of the different problems that you have, but is not going to do a great job at showing you here's how to actually fix something in the context of your environment. And then I evaluate this on a different scale of, is there enough information here for a developer to fix something? Is it simple enough that even a security person could fix it directly? And is it something that could even automatically be fixed? If you focus on actually fixing the vulnerabilities, that's going to be how you're able to actually enforce and show true value in the tool. There have been way too many tools that I've invested in, that I've purchased, that I've spent time uh, pouring in time to set up and maintain, that ultimately didn't lead to the wanted result of fixing the vulnerability. So with all that in mind, that's all I have for today. I'm happy to answer any questions from YouTube or anything. If anybody has questions, yeah, thanks for coming. Hopefully you learned some options for getting security in pipeline.